Hello everybody, welcome back to 25 Days of OlexaKid Christmas. It's 16 days till Christmas, and we have a pretty special video today. A lot of you contacted me and said this is something that we want to see. And it's something that I have wanted to do for a very long time, and I figure there's really no better time to do this than during the 25 Days of Christmas, where we've been trying out a bunch of different stuff and doing a bunch of unique and fun things. This is a little coding tutorial, and it's going to be the very, very bare bones of very basic programming. And we're going to be doing stuff in Python in this video, which is a programming language. There are a bunch of different programming languages out there. Python is one of the easiest to figure out, so I figured that I would do a video just kind of explaining some basics in Python, show you some basics of programming, and hope to inspire you maybe to look into programming as something that you might want to do a little bit in your career. I've talked about this ad nauseum in videos, how important I think programming is, as the logic behind it and stuff like that is just, they're very, very valuable skills, and it's stuff that really should be taught everywhere. So yeah, that's really all I got. Let's get started. I do want to reiterate the fact that you don't just have this stuff installed on your computer to begin with. You have to go download Python from somewhere if you want to code along with me. I'll have links in the description to videos that'll explain a little bit better how to actually download it. I'm not going to cover that in this video, so feel free to pause, check those out in the description, come back, and hopefully you'll have Python downloaded. In this video, I'm using PyCharm as well, which is a, they call it an IDE. Basically, it allows us to code Python in a certain program, be able to run it, see what it's doing, and it's just a very nice tool for Python coding. So I'm going to leave a link to that in the description as well, so you can check that out as well. But let's just hop right in. Once again, this is going to be very bare bones. Any of you that have actually done programming before, this stuff is going to be way less important to you than anything else. I'm not going to start talking about, oh, well, this struct does this and this class does this. It's just going to be very primitive coding stuff. So let's get going here. So I've got the window open, and I'm just in a very basic PyCharm setup here. So I'll kind of show you around. We have our file, edit, view, navigate, stuff like that. We have our run right here, which we can run our code, run Christmas right there. So that is pretty valuable to use, and we will be using that during this video here. And it's pretty straightforward to figure out what's going on in this window. But once again, I'll leave a link in the description to some videos that better explain PyCharm to you. So what is the first place to get started with when you're writing a program? You've never coded anything before. What should you do? And the answer is, you should say hello to the world. It's just the basic thing that everybody does in their very first program, is saying hello world. So the very first function I want to show you guys is the print function. It's pretty straightforward. Print is just going to display something to the screen. Whatever you specify inside of these parentheses, you're going to display to the screen. And for those of you that, I suppose I should start like even before this, for those of you that don't even know what programming is, it's essentially taking data, storing it, manipulating it, and having it do things on a computer that you want it to do. It's a really crappy description of it, and I'm hoping to kind of explain it a little bit better by just showing you examples throughout this video. But say we wanted to display to the screen hello world, then we will put in here, we'll put some quotes because we're going to be putting a string in here, and we'll talk about that shortly. We will say hello world, and that is just peachy keen, hunky-dory right there. We got our print statement, hello world. Let's run our code. So we're going to run Christmas, and then we can look down here at the bottom of our screen. This is where things ran all pretty, and we can see that it has run hello world, which is awesome. It did exactly what we wanted it to, and it finished with an exit code of 0. So this 0 right here, this essentially means success. You have ran with success here, which is good to know for our code. And we'll actually, in case you're more curious about that, let's manipulate this print hello world to actually spew back an error at us, okay? So say that we, instead of spelling it as print, we tried to call the prit function, okay? And to my knowledge, there is no print function in Python. So if we run this code now, we'll come back here, hit run Christmas right here. It's going to run this, and we have spewed back a couple of errors. And we'll come down here, it says trace back to the most recent call. It has the directory in which our file is located here. I just have it on my desktop. It says in line 1, print hello world. The name print is not defined. It's not a function. So we exited with code 1. This means that it was not successful. So you can kind of just see it's going to spew back at you some errors if you don't do something properly. And obviously if we add back in the R for print and then we run our code, we're going to spew back no errors because print is a valid function. We're not going to get too into a lot of functions in Python in this video. I instead want to look at more at like variables and bare bones level stuff. And we'll maybe get into functions if you want more tutorials like this in the future. Like the video if you want to see more coding stuff. I'm perfectly happy doing this kind of stuff. It's just fun for me. I like coding, so explaining it is also fun. I suck at explaining it, as you can probably tell right now, but that is okay. Let's talk about variables. There's a bunch of different variables that you can use in Python, and these are basically like the primitive types in Python. And those of you that have taken coding understand that word a little bit more. But there's 4 main ones that I want to deal with in this video and show you guys. And those are integers, floats, strings, and booleans. So what is an integer? An integer is, I mean, those of you that have taken any math class ever, an integer is an integer. It's very shocking and stunning. We can set integer equal to 14, or 67, or 967. Or 90,435. It doesn't matter. As long as it's an integer, it's going to be able to be stored in that integer slot right there. What is a float? A float is, it's a floating value point, which means that it is a real number. It means that we can have decimals in there. So we can say 65.7. We can say 3.1415926. Or we can say 0.0000009. These are all float values that we can use in our code. Pretty neat. A string is essentially a fancy way of saying words. It's strings of characters. So if we look at our hello world here, the H is 1 character. The E is 1 character. The L's 1 character. I mean, each one is 1 character. So a string is just a string of characters. So essentially, as I said before, in our print statement, we have a string. And we can say that our string is equal to hello world. Pretty fantastic, honestly. We can make this say anything. We can make it say, Tyler sucks at the binding of Isaac. Afterbirth plus. Pretty straightforward with strings there. Booleans are a little bit more complicated, but they're actually very, very easy. Just complicated to understand, I guess. So Booleans can be 0 or 1. And you're probably like, why would you use 0 or 1 when you can just do an integer that is 0 or 1, you know? Why would I spend time making a Boolean? And the answer is, in computer science and in computers, Booleans are always 0s and 1s because those are binary. And I'm not going to get into why binary is binary, how you even read binary, how you understand binary. If this is something that you guys really want to see, then I guess I can go into it in another episode. But in computers, a 0 is usually false, and a 1 is normally true. And it's not always 1, it's just any value above 0 is true. In most languages. Some languages this reverses, and I don't believe Python is one of them, but I might be wrong there. So we can actually say in Python that Boolean is equal to true, or Boolean is equal to false. And these are not words, these are essentially just values. And when the computer reads Boolean equals false, it's actually reading that Boolean is equal to 0, because 0 is equivalent to false. It's a little complicated, and I don't expect you to fully understand that right now, because you're not using it, I guess is the best way of putting it. You're not implementing it anywhere where you can see exactly what's going on, but maybe I'll try to pull an example here shortly where we can use booleans to our advantage. So those are the 4 main data types that I wanted to show you guys right off the bat here. We're going to be using, I think, all of them. Maybe just integers and strings in the example that I have planned here shortly. But I do want to reiterate, so there are many different coding languages, and Python is just one of them. And it's one of the easiest ones, which is why I chose to do this video in Python. I feel it's fairly straightforward to explain to people how Python works. In other languages, if you wanted to declare an integer, say we're working in C or C++, you would have to say that int, and then whatever your name is, x, is equal to your value, is say 10. So essentially what we were doing here, when we were setting integer equal to 10, that's not just making a random integer, that's making a variable whose name is integer and setting it equal to 10. We can make this integer anything. We can make it Tyler sucks, and that is equal to 10, and that is our variable, and Tyler sucks is an integer. It's kind of complicated to figure out, and I'm actually, you know what, let's do a little something here. So let's set Tyler sucks equal to 10, and then let me show you a function in Python, which I don't remember what it is now. Type, maybe. So type, and then we'll put Tyler sucks in here, and then we want to print this. So this is like a very nested amount of functions here. We want to print out the type of Tyler sucks, okay? And we're just going to run this, and then we can come down here to our output, and we first print hello world because we still have that line of code in there, but then it's going to say that the type of Tyler sucks is an int, an integer. Pretty wild. So if we come up here and say we change Tyler sucks to 10.0, we now have that floating point value in here. When we run our code, the class is a float because we now have that floating point value in there that we had before. We'll just do this for the rest of these as well. Let's set this equal to yes he does, which is a string. Tyler sucks, yes he does. We'll run this, come down here, and the class is a string, an str, which is a string. And then finally the last one that we had done, Tyler sucks is equal to true. He does indeed suck. We run this, and well, it came back with a nice little error, so let's instead, well, it came back with a nice little error. I'm probably missing something here. I don't know if it has to be in caps. It has to be a capital T. There you go. So we run this, we come down here, hello world class is bool for boolean. Sometimes I forget my syntax. Okay, it shouldn't shoot me, okay? Booleans, they're fun. Okay, so those are very basic things to do with variables. Let's go a little bit more in depth and do a little bit of math with our variables as well. I'll put back in here all of our values just so we can reference them, our variable type. So there we go, boolean, happy days. Let's do a little bit of manipulation of the variable. So let's set x equal to 10. This is going to be an integer. We're going to set y equal to 10. That's also going to be an integer. And then we're going to set z equal to x plus y. Pretty straightforward. This is going to do exactly what you think it's going to do. We're going to have x is equal to 10, y is equal to 10, z is equal to x, which is 10, plus y, which is 10. So z should be 20. And if we just print z, we can use our print thing with our variable z in here. If we run this code, you're going to see they're yelling at me for these being here. So here's another important thing you can do. You can comment out stuff in Python. If you use a little pound sign, those are just going to be comments now. And these are useful for keeping track of what's going on in your code, but now it's not going to try and run these. So we run this now, we come down here, and z is indeed 20. So we have done everything exactly how we would have wanted that to occur right there. Let's do some more complicated stuff here. So print z plus y plus x. So we have z is equal to x plus y, which is 20, plus y, which is 10, that's going to be 30, plus x, which is 10, is going to be 40. If we run this code, we come down here, we get that this answer is indeed 40. Pretty wild. What are some other things you can do with print statements? We can say print, and then we'll put in here a little string that says z is equal to, put a little colon, put a space, and then we're going to add in that z is equal to, and then we'll put in the variable z. And the plus basically just means that we're adding on to this string. We're concatenating this string with more stuff. So we'll also concatenate this with a period as well. So then we'll run this. We'll come down here. It's going to yell at me saying that it can't convert an int to a string. Why do you gotta be like this, huh? Okay, hold up. I don't remember how to do this. Does that convert it to a string? I'm gonna go out on a limb and say probably not. So now this part of this just goes right out the window. Can't convert int to, I'll show you the error that I'm getting. Can't convert int object to string implicitly. Honestly, don't really worry about this example. I'm missing something stupid, and I'm not going to take the time out of your day to fix this. So let's just come back up. Screw that example. Pretend that it didn't exist. It's going to essentially just print out z when we get the chance. So let's get rid of all of this, and let's talk a little bit about if statements. So these are pretty important in programming. You want to have a if something is true, then do this, okay? So it's basically you put if, and then you put some kind of statement. So we're going to say x is equal to 4, okay? And the equal to, the double equals, let's explain the difference between equals and double equals. Equals you use to set a value, okay? Double equals you use to compare a value. So in this case, we have a variable x equal to 4. This is going to basically say that this variable x is equal to the value 4. Okay? If we have x is double equals to 4, this is saying that x is equal to 4. This is a Boolean statement right here. Okay? This is going to come back as true or false. If we were to print right now, x is equal to 4, this is going to come back true because x is indeed 4. So we'll comment out our if statement. I'll show you guys that this will indeed come back as true, except for the fact that these up here are going to yell at me for syntax. We can come down here and see that x equal to 4 is indeed true because x is equal to 4. It's pretty straightforward right there. So now we can say that, we'll get rid of our print statement. We can say that if x is equal to 4, then print out we've done it. Because we have indeed done it. X is equal to 4. We've set the value. We have done it. So now we can come down here. This statement will not print all the time. It'll only print if x is equal to 4. So we run this. We come down here. And we see that we've done it. What a time to be alive. However, if we change x to be 7. And then we run this. You're going to see real quickly that we have not done it. Because x is not equal to 4. Now, there is a way to manipulate this statement to print we've done it without changing x is equal to 7. And that is what we call the not operator, which is just an exclamation point. This basically means not. That's literally it. So we can come down here and we can say if x is not equal to 4, then print we've done it. And you're going to see real quickly that this is going to work exactly how you would think it would. So if x is not equal to 4, print that we've done it. And we have indeed done it because x is not equal to 4. Does that make sense? I hope that makes sense because we're going to use that in our Christmas example here shortly. If you wanted to have more statements in here, so say if x is not equal to 4, print we've done it. Let's change that back to if x is equal to 4, print we've done it. We also want to say that elif, which basically means else if x is equal to 5, print maybe we've done it. Okay, so this is saying that if x is equal to 4, then print we've done it. But if x is not equal to 4, then check if x is equal to 5. And then if it is, print that maybe we've done it. And then finally we have the catch-all case where else, and then we're going to say print, yes, we have done it. Okay? And that's basically saying that if x is not equal to 4 and x is not equal to 5, then whatever the hell x is equal to, just print that yes, we've done it. And we're going to see shortly, since x is equal to 7, we come down here and it says that yes, we have done it. We can change this to be 4, and it's going to just print we've done it. As you can see right there, we can change x to 5, and it's going to say maybe we've done it because x is equal to 5. That's basically how print statements work, and they're very, very, very important. You use these all the time in programming for many different things, and we'll see an example shortly in the next clip of a time you can use this. I only have one more thing to show you before we move on to our Christmas example here, and that is a loop. And a loop is important for repeating something a certain number of times. Because say we wanted to print the value of x, and we wanted to print it 5 times, okay? We could take this print statement and do this, okay? We've now printed it 5 times, all right? Or we can use a loop, and we can say that while x is not equal to 5, and by that I mean 0, then just print the letter number 5, okay? We'll print 5 times. So then we put another statement here that just says x is minus equal to 1, which means you're going to be doing this statement right here is essentially, I'll put a little comment in, this is x is equal to x minus 1, okay? Minus equals. You also can do a plus equals. So then a plus equals would be x is equal to x plus 1. And that basically just looks like x plus equals 1. You can do plus equals 2, plus equals 6, all kinds of stuff here. So what is this little snippet of code doing? We're basically going to say that x is equal to 5, and then while x is not equal to 0, so we're going to enter this loop because x is not equal to 0, we're going to print 5, and then we're going to subtract 1 from x. So now x is going to be 4, which is still not equal to 0, so it's going to loop again. It's going to continue to do this and print out 5 times, as you can see right here. And that is pretty valuable for our next little example. So let's do this next little example. We'll come back up to our very top here and erase all of this. And I'm going to walk you through a little example that is called Finding Santa's Cookies. Okay, and we're just going to literally call this Finding Santa's Cookies. And this is a comment, so this is not actually running any code right there. It's just for your own viewing pleasure. So what are we going to try to figure out here? We're going to simulate Santa going to houses, okay? And we're going to say that Santa's going to go to 100 houses. And at those houses, if Santa eats a certain number of cookies, then we're going to say he's done it. He has gotten the perfect number of cookies. But if he hasn't, then we're going to say that Santa did not eat the proper number of cookies. So let's define a couple things here. We first want to import a random library. And this is essentially, don't worry too much about this line. You can copy it in, it will work if you're doing this at home. But essentially, we're going to pull another person's code that is doing something with randomizers. And we're going to be randomizing values in this example. So that's why we need this from random import star thing in here. And I can go into more detail with that in the comments if somebody asks me to. But don't worry too much about that. Let's set some values equal here. So we're going to say total houses. So we want Santa to go to 100 houses. Okay? We're going to say the total number of cookies he eats is a thing as well. So that's going to be 0 because he has not eaten any cookies right now. And then we're going to say the cookies at one house is equal to 0. And we'll be changing that value a ton as well. So the cookies at one house is the variable that we want to see, did Santa eat the right number of cookies? And we're just going to pick an arbitrary value for this. Let's say that the correct number of cookies for Santa to eat is 64. You know, my favorite number. That is the correct number of cookies that you should eat at one house. Okay? So then we're going to enter into a loop. And we're going to say that while cookies at one house is not equal to 64, then do all of this stuff. And we're going to enter into the loop here. And we're just going to say, and I'm going to type and then I'll explain a little bit more after. Cookies at one house is going to be equal to a rand int. And this is where we're using the random guy up here. We're going to pull a random integer between 1 and 100. That is essentially what this statement is saying. The cookies at one house, this integer is going to be equal to a random integer between 1 and 100. And it's going to use this total random thing up here to pull a random number. That's all that's doing. Don't think too much about that here. The total cookies, we're just going to do a little plus equals cookies at one house. So we're going to say that the total number of cookies that Santa has eaten is going to be added to the cookies at one house. Okay? Then we're going to say that our total houses is going to be minus equal 1 because Santa has gone to one house. So we want to make sure that that one house is done. He has 99 more to go to try to get the perfect number of cookies. So then we can do an if statement that says if total houses, and by that I mean total houses, is equal to 0, so he's gone to all of the houses, we gotta add a little colon right there, then print out Santa did not eat the right number of cookies. And that is a very bad thing. And then we're just going to exit out of this code here and not do anything else. Okay? So that's what's going on in this. We check to see at each house. We're pulling a random integer. We're seeing if that random integer is going to be equal to 64. If this random integer pulls a 64, then when it finishes all of this, it's going to check, is cookies at one house equal to 64? And if it is, then it's going to exit the loop. And when we exit the loop, we want to print out some statistics. So we're going to print that 1, Santa has eaten the right number of cookies, which is very important for us. He has eaten the right number of cookies. We're very happy. But then let's also look at a couple of things here. We're going to print the total numbers of cookies eaten. So the total cookies eaten from all of the houses is the total cookies. We've been storing that. That's easy. And then we'll also say that the number of houses Santa had to go to eat 64 cookies was our total houses variable. So this should make sense to you. It's not overly complex. It might take a little bit to click in your brain right now, but we are going to track and see what goes on here. And there's no better thing to do than just run this. So we're going to run it. We have not had any syntactical errors. In our first simulation, Santa has eaten the right number of cookies. So somewhere in there, it got 64 cookies as our random integer. The total number of cookies he ate was 1,073, you fat ass. That is too many cookies. And then the number of houses that he had to go to eat 64 cookies was 81. So he almost didn't get to it. He had to go to 81 houses in order... No, wait a minute. No, that's not true. Technically, he only went to 19 houses. Does that make sense? Because we started out with 100 total houses. So then the total number of houses is subtracted by 1. But technically, it's the reverse. It's 100 minus that. So it actually makes sense here to change this value to be 100 minus the number of total houses. That might not make sense, but if you look at it a little bit more closely, you can see that that is actually the right way of doing this. So let's run the simulation again, and what a surprise. Santa did not eat the right number of cookies. So it went through 100 houses and did not pull a 64. We'll run it again. We can see, yep, so in 22 houses, he ate 1,057 cookies, and then finally on that 22nd house got 64. We have here, we got it on the very first house. What a time to be alive. So the total number of cookies eaten, what a great example. Total number of cookies eaten was 64 because he only went to one house. He ate 64 cookies at that house, and therefore he successfully got that number of cookies. We'll do this another time. He did not eat the right number. He ate 2,000 cookies. Too many cookies, man. 44 houses to get there. Not the right number. 3,800 cookies. He went to 77 houses. That's so many houses. And we can actually, we can make this a little bit harder for Santa as well. If we change this to be a value between 1 and 1,000, then that is a much lesser chance of pulling a 64 out of this. And we're probably going to see, so we run it once, Santa did not eat the right number. Run it again, he didn't eat the right number. Do it again. We just made it a lot more difficult for Santa to ever pull a 64 here. It's a 1 out of 1,000 chance that he pulls a 64. It's normally a 1% chance. Now it's a 0.01% chance, 0.1% chance, something like that. There's a reason I have a C in probability and statistics right now. There we go. We finally got one. In 31 houses, he ate 15,546 cookies. That's a lot of cookies. Okay, that's going to do it for this video. If you guys did enjoy this was just a very basic understanding of basic level Python coding. I hope I explained things in a way that makes sense. If you have any questions whatsoever, just leave a comment. I'll respond to everything that you guys put on this one. Like the video if you enjoyed this and you want to see more. Let me know in the comments if you want to see more. If there's a certain area that you want me to delve more into, I would be happy to make some more coding videos and try to teach you guys a little bit more about coding. So thank you so much for watching. More Christmas themed videos every single day of December. I hope to see you guys there. I'll see you next time. Bye.